Hello folks, this is 2022 May-June paper 4-2 and the question number is 5. This question is concerned with capacitance. So the first question is, define the capacitance of a parallel plate capacitor. It is simply charge deposited in one of the plates. So if we have the parallel plate capacitor here, it's the ratio of charge deposited in one of the plates by the PD across the two plates. So charge deposited across one of the plates by PD across two plates. Now, number B. Two capacitors of capacitances C1 and C2 are connected in parallel to a power supply of electromotive force, as shown in figures 5.1. So E. Show that the combined capacitance CT of the two capacitors is given by this. Explain reasoning. So what happens here is, first, the charge given from here, which we say as Q total, is distributed to this capacitor Q1 and then this capacitor Q2. So we must have value of charge Q total will be equal to Q1 plus Q2. So now what I can do is, since we know that Q is equal to C into V, C is the capacitance and V is the potential difference. So this will be equal to, Q1 will be equal to C1 into V here, V, plus this is C2 into V, where V is the PD between these things here. And that's equal to C1E plus C2E here. Similarly, if I consider this whole thing as the single capacitor, then I will have, this is equal to C total into V, or I can say C total into E, because I am considering this whole thing a single capacitor. So if I cancel E here, I will have C total is equal to C1 plus C2. So the total capacitance is simply equal to the numeric sum of the two capacitances. Then the next question is, two capacitors of capacitances 22 microfarad and 47 microfarad here, and a resistor of resistance 2.7 mega ohm here, mega ohm, are connected into the circuit of figure 5.2, figure 5.2. The battery has an e.m.f. of 12 volt. Show that the combined capacitance of the two capacitors is 15 microfarad. So these two are in series, so I must have C total should be equal to, the formula for series is C1 C2 by C1 plus C2, that's equal to 22 into 47 by 22 plus 42 microfarad. It should be equal to, so this gives me, when doing calculations, so it is 22 into 47 divided bracket 22 plus 42 plus 47. So let's do 47 here. 47 is equal to, it is a 14.9855 microfarad, which is equal to 15 microfarad. So the value is 15 microfarad. Then the two-way switch yes is initially at position X, so that the capacitors are fully charged. So they make the capacitor fully charged. Use the information in C1 means this here, to calculate the total energy stored in the two capacitors. So let us take note of this thing, two capacitors. So the U total will be equal to 1 by 2. So since it's said as total, we should have C total into the potential difference squared. C total into PD squared. So the PD here should be equal to same here. This is 12 volt. So it's equal to 1 by 2 into C total is 15 into 10 to the power minus 6 into V squared is 12 squared. So this will give me, so it is 0.5 into 15 exponent minus 6 into 12 square equal to, it becomes 0.00108 joules. So equal to 1.08 into 10 to the power minus 3 joules. So 1.08 into 10 to the power minus 3 joules. Now the last question, the two-way switch is now moved to position Y. So it is moved to position Y here. So this will be cut off here. Determine the time taken for the potential difference across the 22 microfarad capacitor to become 6 volt. So we have to find the time for this to decrease to 6.0 volt. So first we have to find what was the initial PD here. What was the initial PD here? So that requires me to find the Q total. So Q total is equal to C total into V. That's equal to, it is a 15 into 10 to the power minus 6 into the V is 12. So it is equal to, let me have it here. Then the V1 here, let me say this is V1. So this is a V1 here. So this V1 should be equal to Q total by C1. So the charge delivered from here will be deposited here as well. So in series, the charge is same. Charge deposited here and here are same. So the whole charge given here is deposited here. So that's why Q total by C1, that's equal to 15 into 10 to the power minus 6 into 12. And this C1 will be equal to 22 into 10 to the power minus 6. So this goes, what remains with us is equal to, so 15 into 10, 12 by 20 equal to 8.2. So 8 point something, so I can consider it as 8.2 volt. So V1, the value of initial value of voltage is 8.2 volt. So now it has to become 6.0 volts. So that's why V final is equal to 6.0 volt. So the equation for me is V final is equal to V1 e to the power minus t by CR. And since the discharge occurs through both the capacitors, this C should be C total. That means 6.0 should be equal to 8.2 e to the power minus t by CT is 15 into 10 to the power minus 6 and R is equal to 2.7 into 10 to the power 6. So this and this goes. So what remains with us is, if I take a log here, so ln 6.0 by 8.2 will be equal to minus t into 15 into 2.7. So this will give me, if I do the calculation here, so this t, so it is ln bracket 6.0 divided 8.2, right, close, equal to divided bracket 15 into 10, 2.7, bracket close. So this time is equal to 12.651174 seconds. And this becomes 12.7 seconds. So the answer is 12.7 seconds. So this is the complete solution to this question.